This is AP Calculus Review 5 for 5, and this will be 5 multiple choice problems from past AP tests. And the theory behind the 5 for 5 is to do a sample test of multiple choice problems of progressing difficulty and kind of a variety to get ready for the AP test coming up on May 9th. Problem 1. The function f has a property that f of x, f prime of x, and f double prime of x are negative for all real values x. Which of the following could be the graph of f? Well, the first thing we're going to look for is f of x has to be less than 0. And that means we can cross out where f of x is greater than 0, because that'll just make it easy. And so to do that, we see that answer choice E, okay, so E gets crossed out based on that. Next, we have f prime of x is less than 0. So cross out wherever function is f of x is increasing anywhere. Now for that, we look at a, because a, we're increasing from negative infinity to 0, so a cannot be right. So that's not right. To 0, yep, increasing all the way up to x equals 0. See? Function's increasing all the way up to x equals 0. And also, answer choice C, because the thing is increasing the whole way. So C, likewise, is not correct. So now we're left between these two here. Well, we're looking for f double prime of x is less than 0. So cross out where f of x is concave up, because concave down is going to be f double prime negative. Well, if we look at answer choice B, we look like we're concave down the whole way, and it looks like answer choice D, we are concave up this little piece here. So D is our cross out here, and that leaves answer choice B as our correct answer. Next, let's look at problem 2, and for that we have an integration, and we have an x squared times cosine quantity x cubed dx. What we want to do is cross out that x squared, eliminate it to make it easier. And for this is going to be a u substitution. So what we do is we're going to let u equal x cubed. And when we have u equal x cubed, we take the derivative of both sides. Du on the left side equals 3x squared dx. And then if we solve for dx is going to be equal to du over 3x squared. And what that means is that any place you don't see an over 3, well, it looks like everything is over 3. 1/3, x cubed over 3, and so on. So that's not going to be helpful just yet. But we're going to take this function right here, this integral, And we're going to take 1/3 up front like this. That's where the 1/3 comes from. And we have x squared cosine, and we're going to replace that with u. So cosine u, and we have du, and we already have over 3x squared, so we have x squared right here. So right now we've crossed out x squared over x squared. So all we have left is 1/3 cosine u du. Now, I show my students this whole thing, this we call snow cone Santa Claus, where if you go down, you're deriving, and if you go up, you're integrating. So we're taking the integral of this cosine, and so we're going to go up here. So the integral of cosine is sine. So therefore, what we have is 1/3 sine u, and it's going to be plus c. Well, already, anything with a negative sign, that's going to be a goner right there. So we know the thing's positive. And then we're going to re-replace this u with 3x, with x squared. I said 3x squared. I'm going to take this x cubed, excuse me, and go in and replace that u right here. So we have left is 1/3 sine x cubed plus c. So that's going to be answer choice D. Okay. Next. 3. A particle moves along the x-axis so at time t is greater than or equal to 0. Its position is given by x of t equals 2t cubed minus 21t squared plus 72t minus 53. At what time t is the particle at rest? So, okay, particle is at rest where or when t is equal to 0. And to find when that is the case, we're going to find the velocity. V of t equals x prime of t. So we take the first derivative of this function here. So we have 2t cubed, so that's going to be 3 times 2, which is 6t squared. And then negative 21t squared, that's 2 times 21, we're going to have minus 42t. And then we have plus 72. It helps to be able to write 72. Okay, what we're going to do is set this v of t equals x prime of t equal to 0. So 0 equals, we're going to factor out a 6 from each of these terms. So 6 times what equals 6t squared? Well, it's going to be 6t squared. 6 times what equals negative 42t? It's going to be minus 7t. And finally, what times 6 equals 72? That's going to be 12. And so if we divide both sides of this equation by 6, we have 0 is equal to, and we can just factor this guy right here to quantity t minus 3 and t minus 4. And so solving, we're going to have t is equal to 3 and t is equal to 4. So our correct answer is E. Now, I've seen students get this wrong because what they've done is sometimes they've taken the second derivative and set that second derivative equal to 0. I think that's how somebody got 7 halves. But anyway, this would be the correct way to do it, correct solution. Next, 4. Uh, let f be the function given above. It's a piecewise function. Which of the following statements are true about f? Well, limit as x approaches 3 of f of x exists. Well, for the limit to exist, the limit as x approaches 3 from the left side of f of x has to equal the limit as x approaches 3 from the right side of f of x. And so we just take both sides. The left side is going to be x plus 2, and we set that equal to the right side, which is 4x minus 7. And if we substitute in 3 for each of these, we have 3 plus 2 is equal to 4. It's equal to 4 times 3 minus 7. So we get 5 equals 5. And so we know that since the left side limit is equal to the right side limit, we know the limit exists. And we know that. And we know, because we have this less than or equal to sign, that f is continuous, because right there at x equals 3, the function is defined at that to be 5. So we know that's correct too. And so the only thing we're really lacking is this last piece here, which is for differentiability. And to do that, we do the same as for continuity, but we say the limit as x approaches 3 from the left side, not of f, but of f prime of x, equals the limit as x approaches 3 from the right side of f prime of x. So we're going to take the first derivative of each side. Well, the left side is x plus 2. The derivative of that is 1. The right side is 4x minus 7. The derivative of that is 4. Okay, and so now our conclusion. Since limit as x approaches 3 of f prime of x does not exist, they're not the same, that limit does not exist, f of x is not differentiable. And so that's going to be an x. So we go for where 1 and 2 only are displayed. And what that looks like when we graph it is going to be something like this. You have an x-y coordinate plane. You got evaluated 3, and to the left of 3 you have this kind of looking function, this x plus 2, going up like this, x plus 2 till 3, and all of a sudden you shift over to 4x minus 7. So you're shifting suddenly to a slope of 4. And so this corner here means the function is not differentiable at that point. Okay, the last one, 5, d dx of the integral from 0 to x squared of sine t cubed dt. This is called a second fundamental theorem of calculus problem. And to do that, if you have a constant that's 0, doesn't matter what it is. This could be 1, negative 50 million, doesn't matter. But this x squared is key. You take this x squared, the top limit, and you'll substitute in for that t right here. And then you'll multiply by the derivative of this x squared. So what that's going to be is sine. We take this x squared, we've replaced that t, and cube it out here, and we multiply that by the derivative of x squared, which is 2x. So what that gives us is 2x sine of x to the 6th power. And which one's that going to be? It looks like it's going to be answer choice E. So anyway, that's the 5 for 5. I hope this has been helpful to you. Good luck, and as always, thanks for viewing.